Right. Today we are talking about CLIP. So the paper title is Learning Transferable Visual Models from Natural Language Supervision. It came out in 2021 out of OpenAI. And it's CLIP because it's contrastive language image pre-training. It's a very impactful paper. I think it forms the basis for vision and text models. And there's been a bunch of advancements since there. And over the next few days, I will read a bunch more papers that were based on this and kind of address some of the downsides and take the ideas further. But I wanted to read through this one first. It is a very long paper, so I'm not going to do it justice. I'm mostly going to mention the context around it and the main ideas, but there's a lot of detail that I will skip over. So what this paper does is it trains a multimodal embedding space. So multimodal because it's images and text. So it puts the two together and it learns to predict which captions go with which images. And that seems like a very specific task, but it turns out that by training a model to do this, you end up training a model that transfers well to other tasks. And they talk about that as well. So you can do image classification, but you can do also a lot of other things that only happen when your model learns useful representations, like sort of representations together of text and images. And this work was inspired by NLP work, where you have giant amounts of text on the internet, and turns out that if you just create a model to predict the next token based on all the text that you have, you end up creating a model that sort of seems to understand text. So they figured out how to do a similar thing with images and text. So basically, they scraped the internet and found all the images with captions, and then trained this model to predict captions for images. And the way this works is there's an image encoder and a text encoder. So an image encoder takes an image and produces an embedding, so a vector of images, a vector of numbers. And a text encoder takes a piece of text and produces a vector of numbers. So all of these, both of these things are pretty straightforward and like trainable. And the innovation is putting these two together. So you take an embedding of an image and an embedding of a text, and it should cosine similarity of these two should produce a number that is high. But if you take the same image with a different piece of text that does not describe this image, then the cosine similarity of these two should be small. And that's basically the objective they optimize. And turns out then that by doing this, they create this multimodal embedding space where images and relevant texts end up being close to each other, and the ones that are not related end up being far away from each other. So at test time, you can give it an image and a bunch of different pieces of text, and by doing the same thing, you will find the text that most likely describes this image. So that's the overall idea. Obviously, there's huge amount of detail here, how the architecture is structured, how they kind of make it computationally efficient to train this, how they gather the data sets. I'm going to skip over all of that because we don't have time. But this gives you the main idea for how this works. And it turns out that this is a very effective way of doing it. And you can fairly efficiently train a model that does really well across a broad range of tasks. They have some interesting adaptations, but I'm going to skip over them. But one interesting thing is that you can think of this whole system as a hypernetwork that creates linear classifiers. So in this world, and they mention this in the paper, the image encoder is a feature extractor. So it takes an image and outputs a bunch of numbers. So it's a feature extractor. And then text encoder is a linear regression classifier producer, like a factory of classifiers. So it takes a text and outputs a linear regressor that learns to predict like images that go well with that text, that match this text. So that's kind of what's happening. It's just kind of a fun interpretation. So this is basically it about the meat of the paper. There is a giant section on experiments, which I'm going to skip right through because it's giant, but it's very comprehensive, which is really cool. I really like the limitations as well. Again, I'm going to skip over it, but I appreciate that it's big and comprehensive as well. They also have a whole section on societal impacts, which is also really cool. But yeah, took a while to read this paper. It's really interesting, really impactful, and I'm looking forward to reading the follow-ups.